Hello, welcome to the part three of transaction management discussion. So we're done with what the transaction is, how do we do save points, what is a scheduler, what are concurrency control problems, the asset properties, what are the locking mechanism or locking methods. So let's go now to concurrency control and management. So let's go first with different lock types. So when you say lock types, regardless of the level of locking, whether it's database, table, page, row, then the DBMS may be or may use different lock types. So it's either binary lock type. So when you say binary, that is 1 0 or lock unlock. Or we have the shared or exclusive lock type. So let's discuss one by one. Let's go first with binary lock. So as mentioned earlier, when you say binary lock, you only have two states. You have locked or unlocked, one or zero. So when the particular data item is currently being used by a transaction, then that particular data item is locked by that transaction. Unless the transaction has been completed, then that's the time that the data type can be released from its lock or it will be unlocked and it can be then accessed by another transaction. So, for example, this is what we call or an example of a binary lock. So, transaction one requested for the product table, and in the product table, the lock has been granted so that transaction one can update the product quantity on hand. Once transaction one has finished its update, and that's the time that the product table will be unlocked and other transaction can access it. So in this case, it is transaction 2 who is currently or who is now holding the lock. So as you can see, when T1 is accessing product, the status of the product table is locked. So that is 1. Once transaction 1 is done, then the state of the table is already unlocked or 0. So once unlocked, then other transaction can access it and feel the same. Transaction 2 will lock and during its execution of the transaction and unlock the table once the transaction has been completed. So that's for binary lock, and it's the very simple locking mechanism. Or yeah, no, lock type rather. Let's go for the second lock type. The second lock type is what we call the shared or exclusive lock. So this goes together. When you say shared lock, meaning the two transaction accesses the same data item. However, the access is only read, meaning they are only viewing the reading the data item. So two or more transactions can have a shared lock by reading only the data item. Now, when can we say that a transaction will be exclusive for a for it? So an exclusive lock, it will exist if a particular transaction will will make changes to that particular data item. So the first to request the exclusive lock for data item number 1 will be granted. So example, transaction 1 and transaction 2 are accessing data A. So but in the first level, it's still shared lock because they are reading data A. Now, transaction 2 wanted to update data A. So it requested for an exclusive lock. Then the lock manager will check if transaction if that particular data has been locked exclusively or shared. Pag shared, then i-grant niya ang exclusive lock to transaction 2 for data A. So the transaction 2 can perform the changes for data A. Once done, then the the exclusive lock will then be released. So that in case the transaction 1 would like to update data A, can also perform or can also request for an exclusive lock of data A. So once done again, then the exclusive lock will be released. So that's what we call the uh what they call this one shared or exclusive lock. Okay, so we have two types, or we also have what we call the two-phase locking. So in two-phase locking, first is it defines how transactions acquire and relinquish locks. So in two-phase locking, it guarantees serializability, but it does not prevent deadlock. So in two-phase locking, we have the growing phase and the shrinking phase. So when we say growing phase, the transaction acquires all the necessary locks for a particular or for any data that will be involved in the transaction for transaction 1. So once na isa na ma, ma-finish or ma-complete ang mga transactions to their respective data items that has acquired lock during the growing phase. During the growing phase, then that's the time that each transaction or each data item will be released from its lock. So that's what we call the shrinking phase. So let me repeat, growing phase, that's the time that a transaction will acquire all the necessary locks from any data that the transaction will be updating. So after each data has completed its designated transaction, then the lock for that data will be released. So the release of the lock is what we call this one is what we call the shrinking phase. So this is an illustration of how two-phase locking works. So in the growing phase, the transaction acquires all the locks for all the data items that it needs to access. So once locked, then that's the time that it will do the changes or the transaction will be executed. So once transaction is done for a certain data item, the lock will then be released for that particular data item until all of the locks are released for each data item. So this part here is what we call now the shrinking phase. Now let's go to deadlocks. So when you say deadlocks, this is this is the most dreaded part of concurrency access. This should be avoided. So when you say deadlocks, um, let me give you an analogy. Example, you are in the intersection. So everybody is familiar with the intersection going to Ketkai, right? From USTP to Ketkai and going to Agora. Okay. So when the cars from USTP will go straight to Agora, it will pass the crossing. And then suddenly a car from Ketkai will cross the intersection from Ketkai going to USTP. And then at the center, they what they call this one, they they stop because if one will move, if the car going to a car will move, it will clash or it will collide with the car crossing from Katkai to USTP. So they are waiting for each other to give way so that one can go to its destination. So the longer the time that they have waited and no response, nobody gave way, then that's the time that deadlock occurs. So also in database, it also occurs. So when you say deadlock in database, you are you have two transactions trying to access the same data. Okay, so example, let's have here transaction one. Transaction one has a hold or is accessing data items X and Y. Now, data item X is currently being locked. The lock for data item X is being uh, held by transaction 1. And transaction 1 wanted to access data item Y. On the other hand, transaction 2 is currently holding the lock for data item Y. And transaction 2 wanted to access data item X. However, T1 did not release the lock for X. And so with T2 did not release the lock for Y. So T1 now is waiting for T2 to release the lock of Y, and T2 is waiting for T1 to release the lock of X. So the waiting period there, the, the, the waiting period there will cause deadlock because no transaction released the lock of the data item that the other transaction requested. So that results to deadlock. Okay. So we have three basic techniques in controlling deadlocks. We have deadlock prevention, deadlock detection, and deadlock avoidance. So when we say deadlock prevention, the transaction requesting for a new lock is aborted when there is a possibility when the transaction manager or the no lock manager, the scheduler, can detect that there is a possibility of a deadlock can occur. When you say, so that is before the transaction has been granted the lock. When you say deadlock detection, the transaction is currently being executed. The transaction has been granted with the lock. However, if the transaction manager can detect that there is a possibility for deadlock along the process or along the execution of the transaction, then the transaction will be aborted. Okay. For deadlock avoidance, so in deadlock avoidance, the transaction must obtain all the locks that it needs for its data items to be accessed before it can be executed. So we have here what we call the concurrency control with time stamping. What do you call that one? Time stamping. Wait for a while. Time stamping method. So timestamping method, this approach to scheduling concurrent transactions assigns a global unique timestamp to each transaction. So every request or every transaction has its own unique timestamp. And it will be or what they call this one, it will be processed sequentially or chronologically. So the first to request a lock, then that will be the first one to be granted. So that's for time stamping. So in time stamping we have here the wait or die scheme. So we have two two types. So in time stamping we have two scheme. wait die and wound wait scheme. So when we say wait die, so if the transaction requesting the lock is older of the two transaction, it will wait until the transaction or the other transaction is completed and the locks are released. If the transaction requesting the lock is younger of the two transaction, it will die or roll back in the and is rescheduled using the same timestamp. So meaning transaction 1 is older than transaction 2. Now transaction 1 requested for data A and transaction 2 also requested for data A. Okay? So since older man si transaction 1 will wait for the previous transaction to finish so that transaction 1 can acquire the lock for data A. Okay? And transaction 2 will wait for transaction 1 to finish that and the execution in data A so that the lock from transaction 1 will be released and transaction 2 can then uh, acquire the lock for data A. But on the other hand, transaction 1 is older than transaction 2, meaning transaction 1 requested first and transaction 2 also requested. Now, if transaction 2 is the one tried to what do you call this one? Hold the if the transaction if what I call transaction 2 is the younger one tried to request the lock, then transaction 2 will be rolled back or will die so the transaction 1 can acquire the lock first. But transaction 2 will go back to the scheduling table but with the same time stamp so that it will be accommodated uh, first on the next round of rotation. So that's for wait die scheme. Okay, so in short, the older transaction waits for the younger transaction to complete and release its locks. So we also have what we call here wound wait. So if the transaction requesting is the older one of the two transaction, it will attempt it will preempt the younger transaction to roll back. So if the transaction requesting the lock is younger, it will wait until the other transaction is completed and the locks are released. So in short, wound wait scheme, the older transaction rolls back younger transaction and reschedules it. Then we also have here the optimistic approach. So when you say optimistic approach, each transaction moves through two or three phases referred to as read, validation, and write. So we have the read phase. So when you say read phase, the transaction reads the database, execute the necessary computations, and makes the update to a private copy or a temporary updated file. Okay, so that's for the read phase. So the updated version of a data will temporarily be saved in temporary file. So after the read phase, it will proceed to the validation phase. So when you say this will validation phase, this will ensure that the changes made and that has been saved temporarily in a the temporary updated file will not affect the integrity and consistency of the database. So if makakos siya og inconsistency, then the the transaction is restarted. If dili siya makakos og inconsistency, then from the validation phase, it will proceed to the write phase. So in the write phase, it is when transactions or the changes are made permanent to the database. All right, so now let's proceed with database recovery management. So in database recovery management, this is where you have a strategy as to in case of hardware failure, software failure, or power interruption, there is a way for you to recover the database from the last consistent state. So when you say database recovery, so that is recovering the database from its previous consistent state. So in recovery techniques, this is based on atomic transaction property. So all portions of the transaction must be treated as a single logical unit of work, which should be completed at once. Kung dili siya ipadayon. So critical events, you have here mo na kung mention software or hardware failures. In case magubay mo hardware, magubay mo software. Human caused incidents like accidentally pouring water into the servers or tawag ani na nabundak, nahulog, that's human caused incidents or natural disasters like the baha. So we should always have recovery techniques. So in transaction recovery, we have the write ahead log protocol. So with this write ahead log protocol, this ensures that transaction logs are always written before any database are actually updated. So this protocol ensures that in case of failure, the database can later be recovered to a consistent state. So basically, mauni gamit diri si trigger. So any update, tool update before update dapat na kay tawag na kay before update in a table so that you can the purpose for the logs in before update is for you to be able to retrieve the previous state of your database, previous consistent state of your database. So that's how logs or audit trails are important. Then we also have here redundant transaction logs. So when you say redundant transaction logs, you have multiple copies of your transaction log. So this will ensure that in case of disk failure and it's unrepairable, then you can you can use another copy of your transaction log to recover your data. You also have here database buffers. So these are temporary storage areas in primary memory that is used to speed up disk operations. This is to improve processing time. And the database software reads the data from the physical disk and stores a copy of it in the buffer of the primary memory. Then we also have here database checkpoints. So these checkpoints are operations in which the database writes all of its updated buffers into disk. So meaning at a certain point in time, at what point? So checkpoints contain the the time when all the updated buffers or all the updates that has been saved temporarily in the buffers will be saved permanently to the disk. All right, so that's for transaction management. So there will be another set of quiz and we'll have another topic next day. Thank you and good day.